Good afternoon, everyone, and thank you for attending our PCB Design Top Factors Related to Data Routing and Layout webinar. My name is Ryan Wood, Content Marketing Manager here at Epec. Before we get started, I just want to let you all know that you'll be muted during the presentation. If you have any questions as we move along, please enter them into the questions panel, which is located in the webinar control panel, and we'll try to get to all of them at the end of the presentation. If we don't have time to go through all your questions, we'll be sure to reply to you by email. Also, we will be recording this webinar and we'll be posting both the recording and the slides on our website and YouTube channel. Our presenter today is Angie Brown, our PCB product manager here at Epec. Angie has over 40 years experience within the PCB industry. After spending several years manufacturing PCBs, she turned her focus to CAM engineering and has worked on processing thousands of data sets. Angie has also has production background, which has helped improve every manufacturing process. As the PCB product manager, Angie acts as the main resource for Epec's PCB product solutions. She works closely with customers to assist in their PCB designs to help improve or resolve any data or technical issues. And Angie oversees Epec's entire CAM engineering team to verify a seamless transition for all orders from the time of the quote to final production. Angie also works closely with our engineering, quality, and sales teams on various circuit board related projects. So without further ado, I'll pass it on over to Angie.
Thank you, Ryan, and thank you everybody for joining me today on our webinar for layout and routing of PCBs, top related factors. As he said, I'm Angie Brown. I've been with Epec for 20 years, and 22 years prior to that, I did manufacturing of PCBs. So it's kind of in my blood. So let's get started on the webinar and see where we go. Thanks. So our agenda today, layout and routing. So this is the step before typically where I get involved. So this is after you've come up with your concept and you've got your layout. When to ask for PCB manufacturing input, how Epec can help, production design, customer collaboration, PCB data processing and lamination limitations, other data considerations, UL, date code, and markings. So as we get started, I just put up this picture so everybody could see a finished layout and routing of a board. You can see the intricacy of the board, the BGA, the components, the resistors, everything laid out. This is a multiple layer board with gold finger tabs at the bottom. So your project and what Epec would like to know. When we get PCBs in the door, usually we get the data and it's all ready to go. What we would like to do is get involved before that at the layout and routing stage. And why? Because we manufacture PCBs and we can sometimes add to your layout and routing and prevent issues along the way in manufacturing. So PCBs are intended to function, what the function is, what your board is intended to go into. What is your end product? Is it going to be ITAR, military, medical, automotive, or domestic? What your power requirements are, input, thermal, distribution, what the layout is for those items. Challenging environmental concerns such as humidity or extreme heat or extreme cold or vibration or a combination of those. Defining the constraints of the board, X, Y, and Z, your total length, your total width, and your total thickness. Is there a budget for layout and routing? And where are you with a timeline for that? So another thing that we would like to know in advance is your components and what your project is defined as. So we can have the right components and the right specifications to begin with. Considering your cost, availability, and your alternative, your compatibility and your reliability. How to choose your components, reviewing data sheets, documents, manufacturers, any information that you can get online. Most manufacturers of components have downloaded data sheets that you can pull from online. Watch out for your voltage parameters, your signals, your temperatures, communication specifications, and what your footprint or your land is going to be for that requirement. So defining more information for us, any critical placement, depending on the function and the connections and where those need to be. Is there anything that we need to know? Have you experienced using these components and had any issues with crosstalk or noise? Is there any projects from the past that we should know about that there was a concern? Keep out areas. Assembly text can sometimes need to be visible at the final assembly. Cutouts for pass-throughs of cables or components that drop down below the board surface, any kind of overhang. And of course, your BOM, your schematic, and your outline. So design, routing, layout needed. Critical things for us to know in advance are about your signal integrity. So the travel of that circuit to its end destination. Of course, your power integrity, providing adequate power supply to support the unit as needed. And your electromagnetic compatibility, so to prevent any outside interruption by any other devices or components. Your compliance standards that are needed. IPC 2221 is your generic spec for all things component placement and high voltage. And IPC 6012 is your PCB manufacturing standard. That is what Epec uses to manufacture to. IPC 6012, the latest revision, Class 2 and Class 3. Class 2 is the most commonly used. Class 3 is an equivalent to military. And over here you can see a completed PCB with a split plane and some intricate cutouts. So if you had told us that this board was 4 inches square, but all this was missing, we could potentially route into this area and lay out. So knowing the exact dimensions of a board and what that profile looks like is critical. So again, our starter checklist for the design group: BOM, schematic, and outline. Those are the 3 things that we need for review for us to quote your layout and routing. That's the short list of must-haves, but what we need up front. So this is a bill of materials that I had put on here, that it's perfection because it absolutely gives us everything that we would like to know up front for layout and routing. It gives you a list of your components and the quantity, the designator for each, the value, the footprint, who the manufacturer is, the manufacturing part number, the DigiKey part number, and a description. With all of this, we can easily find what we need for that footprint and component layout. Schematic formats. We see many different schematic formats come in. The best is Eagle, Altium, Mentor, but we even use PDF. We've had hand-drawn schematics come in, and we'll work with you to clean those up and make them something that we can use to import. A schematic allows us to assess the complexity of the scope of the design. With a good understanding of what you have at the quote, it's an easier transition into getting your board designed and laid out. We can provide a CAD format back to you in your preference, whatever you want us to send. If you don't tell us what you want to receive, we will choose what we believe is best fit. Some of the options are the Cadence Allegro, Mentor pads, Expedition, or Altium. So here is a schematic to capture. It's done in a nice clean format. It's got all your components and all your trace layout and where you're going to put each, or what each connection is going to look like. Some of the times this is what we receive. So it's just hand drawn. It's got some of the clear designators or components that we need. But something like this over here, not really sure. Is that a 5? Is it a 6? Is it an 8? So in this case, there will be some questions. We'd still be able to provide a quote, but there would still be some clarification needed. And last but not least is your outline. If we receive this in a hand-drawn format or PDF or DXF, any format that depicts what the board looks like. And if you can show us where the approximate place out for a cutout will be, that will help us too. It doesn't have to be perfect, but this is a keep out area. It's a drop through for a cord, or it's just for a component overhang. This is a flex board here. These areas are pass through for the flexible material. These are cutouts. So obviously we won't be placing any components in these areas. Where this part here and here is more of a rigid, and also down here, again, this is keep out area. We wouldn't place a component here. There's also some cutouts in this end of the tab. There may be some minor components placed, but there's not a lot of room. Again, another flex board with a component on the end. The only place to populate this board is here in this odd shaped area. Another outline with some gold finger connector on one end, but a cutout on each corner that are keep away areas. And even this one, not perfectly square. We would need to know about these corner chamfers so we don't bring any components out towards this edge. So design, layout, and routing. Where we want to come in is after electrical engineering, after the concept, after the project's been laid out, after the components have been picked, and when your timeline is right for us to be involved. Epec started offering design services at the request of our customers. When customers were coming to us asking us for assistance, we reached out to some really good suppliers, domestically and offshore, to provide a service at the request of our customers. So we would also like to know, is it ITAR and domestic only, or can it go offshore for assistance? So again, why Epec? Well, because we're build-to-print manufacturing of PCBs. Knowing more before the board is ready to go into production only helps us all for an easier transition through production. It builds a perfect relationship to involve us during your process of getting your board finished, because we can then take the data, massage it, look at it with our team for layout and routing, and make suggestions to improve it before it's back to you to go to production. So as I said, when to ask for PCB manufacturing input, for us the answer is after electrical engineering has completed the concept. Once you have your schematic completed or nearly completed, there may be some clarification needed. Your BOM, once that's completed, we need the part number, the quantity, manufacturing part number, if an alternate is going to be allowed. Some components are in short supply, we all know that. So giving an alternate to a component is advantageous to your assembly house getting the boards to production quickly. Any non-standard or specialized components used, if you have data sheets on those, we appreciate getting those up front. And include any components or hardware that may be involved with the project. Your outline, like I said, one-to-one with what your intention is for the area of usage. It doesn't have to be the exact, but we need the overall X and Y distance, longest distance, both directions. Again, if you have any cutouts or critical component placements, if you can let us know those as well as mounting devices. So if you have some mounting holes that you need specifically met in those dimensions, or countersinks or counterboards, if you can let us know that at the time too, that'd be good. So further discussion, we've received in your BOM and your schematic and your outline, and there's been some back and forth with our customers in Epec. What we'll do at that point is we'll engage with our design team. We'll share information, what we've learned to this point, prepare to have a quote or have Q&A with the customer. What other information is needed. There may be some email back and forth and some conversation, but most of the time a call is best and getting everybody on the call together. Manufacturing of engineered products is what we do, and getting everybody on a call sometimes is the best way. So we prepare our members and have a call. So our intention on this call is to get an overview from our customer, get a brief description of the project, what it's going to go into, what the environment concerns are, if there are any, what your timeline is, if there's any certifications that are needed for the board to meet, if there's any testing needed that has to be done up front, if there's impedance testing, in-circuit testing, is there any access points that are going to be needed after assembly? Impedance controls, intended materials that you have in mind to use. I have a caution here because anytime you directly put a specific material into place, that can come with lead time issues, added cost, availability, and not always accessible at all locations depending on the technology of your board. So considering a material, considering an alternate, something else that can work with you and for us all is better as far as pricing and delivery and lead time. Is it high-powered or high speed or power distribution or voltage that we need to know about? And any compliances that we have to follow. So ITAR, obviously, there's a sharing of data. Epec is ITAR compliant. We do not share data over email. We have a secure website. IPC, UL, RoHS compliancy, any certification that may be required along the way. And as well as markings, if there's a specific part that you need to have marked with a specific compliance. So considerations for layout and routing. I did a little side-by-side chart here with the difference between the electrical engineering and the routing and the layout. So if you look at the left column, this is all electrical engineering. So your PCB design and engineering, overall circuit functionality and electrical design, your concept, your schematic is built, your knowledge of electronics, circuit theory, signal integrity, and your schematic and BOM have been developed. Over here on the right, PCB layout and routing, this is where we want to come in. So creating your Gerber data files, coming up with your exact outline, the physical placement of your components, and trace routing. This all begins after the schematic design is complete. Understanding the complete manufacturable design, complete set of Gerber data and drawings to be provided. So a schematic capture is when we take what is provided from you to us in a clearly drawn format and we redraw it with a CAD tool. Most often we use Eagle, and this is part of your quote that we supply to you. We'll pull in your symbol representation of your components, your chips, your resistors, and your nets. Once the schematic has been captured and drawn in Eagle for layout and routing, the symbols and the representing chips and resistors, etc., will all connect to the nets that are required for the PCB to function. When it's done correctly, we can probe those points and see the locations on the schematic, and everything will come together neatly. So the rest of the board layout, what else we need to know, understanding layout and routing and complexity of the project. So as I said, the component placement, what your choices are, your equivalents, your placement, your keep outs, your cutouts, anything about the physical finished board that we need to know that isn't part of the schematic. Trace routing and your impedance controls, if you can call those out on your schematic as a side note, that's good for us as well. Your design rules, trace and space clearance, that's not always up to you, sometimes driven by the components. We'll work with you on some of that if we need to make any tweaks or changes to it. But if you know anything that we should know up front, please give us that information as well. So setting the design rules within the program, we have to set our line widths. So there's a max and a min setting and a preferred. Signal integrity, as I said, that's where making sure your signal gets where it's got to go without any problems or interruptions. Impedance controls, the travel of that circuit to get from A to B is critical to the line width, the copper thickness, and the length of that trace. High-speed component placements, again, minimum trace length. We don't want to have that signal travel too long and not function properly. So routing begins after we receive in all the information and after we've talked about what we need to do. We'll use your outline as shown here on the right. And we'll start with the placement of the components, which is all of the green. All of the ones at the bottom are components that are left to be placed. And the lines drawn with yellow to the components within the board are the nets, showing where those connections are going to be. And I said art of placement on this slide specifically because it really is amazing what our designers can fit onto a board and have it function properly. They can optimize it without compromise. They know where to put everything. It really is a nicely drawn out PCB when they're completed. So routing begins after we've got some components placed. You can see here now, same board, we have dropped on plenty more components and the traces have started to be routed in, which is the red or the blue that you'll see. As the land changes where we're placing components, there may be room to move some of the components around. We may have to drop down and add some of those components to the bottom side. Depending on how tight the spacing is, there may be some other changes that need to be discussed, such as a change to layer count that we initially might have talked about. Sometimes you don't really know how many layers it's going to be until you get into the layout and the routing. And then we'll also discuss with you options versus the cost. So there could be a difference between adding a couple more layers or adding in some blind vias. So your final routing is done and your components are all placed and your circuitry have been placed from component to component. All the tracers are on top, bottom, and maybe on an internal plane. So what are we missing? Well, if we haven't gotten everything placed, we may need to drop down and add layers. Versus adding blind and buried vias, adding a layer is always going to be least expensive than added blind or buried vias. So one side versus two side components versus 2-layer versus 4-layer, 4-layer versus 6-layer, always a better option than to add blind and buried vias. And we can help you decide that. So here's a good example of a couple of completed PCBs that have been routed. I just picked these two because I thought they were pretty interesting. They've got a lot going on both of them. They've got some quad flat packs and some BGAs, some intricate cutout areas, some routed channels. Just overall, some nicely laid out boards. So vias are our communications specialists. Without them, I don't know what we would do. The vias have the same format as getting them ready in the system. They have a max and min size and a preferred size, as well as a pad size. So in this picture on the right, you can see all of the green holes are component holes. They're drilled on the final layup of the board. They go from top to bottom. There's no blind or buried that are green. Everything else, the peach and the purple and the red and any other color you can see in there, those are all buried or blind. There are no back drills on this picture, but we also do back drilling to remove the plating from one side or the other. We also do vias for removing of heat away from components. There aren't any on this board, this picture on this one, but it is possible to add vias to layers to help disperse heat from components. So a little bit more about impedance. So opposition of electrical circuit when alternating current is applied. Most often we use the 50 ohms as our measure because it's the least bad between all the other options. Minimum loss, max power, maximum voltage. Impedance is driven by trace width, thickness, and dielectric as well as length. Knowing what those impedance values are up front helps us with our placement of those impedance traces. And if you, again, mark the impedance on the schematic, that will help us up front. So impedance in copper, as I said, copper thickness, trace width, performance, as well as the length of that trace. Allowing for some compensation during production only helps us to build a better board. So when you're bundling circuits together, even if it's just a pair of traces, and you have those up against each other and there's copper or holes left or right, it doesn't leave us much room to add compensation to the trace so that we can then have an etch factor to meet mixed core technology. Mixed core technology is when one side of your core has half the ounce as the opposite side. So half ounce on one side versus 1 ounce on the other side is more difficult to produce. It's a manufacturing challenge. It's come a long way, but if you can give us a little more room instead of a 3 mil space, 3 mil line, 3 mil space up against vias or copper, better for us. This is something that we would see coming in on production, on data sets for production. Copper pour on your outer layers always helps with impedance and with etching. Teardropping your pad to circuit, if you have a tight pad to circuit annular ring and your aspect ratio is tight, if you add a teardrop from pad to circuit interface, it just improves that connection. Circuitry impedance by width or layer. Typically, we upsize the circuit that is impedance by 0.0001, just so we can pull it out at manufacturing. We can define those by layer. So just a little trick on the side to easily pull out the impedance circuitry. We'll add fab nodes for the ohms to meet the plus or minus 20%. And we typically like to use solid ground planes versus broken ground or power planes. So partnering with a PCB manufacturer, as I said, we've been in this business for many, many years. And partnering with us, we work with design, layout, routing customers to meet the manufacturable PCB that you need out the door. We don't want you to go through costly prototyping only to find out that something wasn't right from the beginning. So behind the scenes, what we have already done is we have vetted the customer for the opportunity. We've set them up in our system. We've done credit applications, terms, credit card, financials, NDAs are in place. We'll work with our customers to set all of that up, and then we'll have our deliverables laid out. So after final schematic diagrams are done, the PCB layout, RS-274X formatting for Gerber files, fabrication drawings, NC drill, and even a finalized BOM if something was changed in between. So what else would you get from Epec? Well, because you're working with a PCB manufacturer at this point, and we're at the beginning rather than at the completion of your data layout, we'll do a complete DFM. So my team of engineers here in the United States will take your data that's been completed by our design team, and we'll run the data through a DFM. And there may be some back and forth between us and layout and routing to make a change, pull some copper back, tweak some layer information, come up with a better layout for a specific reason where we have no room to do that etch compensation. In working directly with the design team, we perfect the data to go to production without having to worry about manufacturability. So it is important to talk to your supplier. Having us involved during development stage, we're familiar with the product, we're familiar with the people we're talking to. We know manufacturing. We've been doing it for many, many years. And in some cases, we can provide that cost savings. Like I said, the material suggestion, you may come back with some exotic material that's not commonly stocked, and we can say, well, you know, rather than this, although we can get it, but there's a 12-week lead time, if you use this, it'll give you the same PCB for a lesser cost. It's repeatable, the material's commonly stocked, and it won't be hard to get from lot to lot or from order to order. The complexity, we know in manufacturing what we can and can't do. We'll review the data from layout and routing, and in some cases, the board is more complex than we can currently meet with our capabilities. It doesn't happen often, but there has been a few cases where it's all set, it's all laid out, it's all routed, we've done our due diligence, and it's just not manufacturable for us at the time. Not all manufacturing is created equal. That's why Epec has developed a supply chain across the country and across the world so that we can meet all of our customers' needs for all types of boards. So in summary, today we've reviewed Epec services and advantages to design, layout, and routing. As a partner in common goal of getting your product right, we want to help you with your projects long before they're ready to be placed into production. How can we do this for you at a lower cost than internally hiring new people or sourcing a second party? Design and layout and routing is something that we've been doing for many years. And as we have manufactured boards for all types of customers, aerospace, military, automotive, commercial products, we believe that we can fit your every need.
Thank you, Angie. Now, while Angie reviews the questions that came in, I wanted to briefly mention some of the additional products we offer here at Epec. Epec has designed, our expertise here not only lies in more than 70 years of manufacturing printed circuit boards, but also in custom battery packs, flex and rigid flex PCBs, overmolded and other types of cable assemblies, CNC machining, high reliability user interfaces, flexible heaters, and energy efficient fans and motors. Next slide, please. And now I'll turn it back over to Angie to go through some of the questions that came in.
Thank you, Ryan. So a few questions that came in. I don't know if I'll get through all of them, but I did mention impedance quite a bit. You're correct. To explain a little bit more about impedance and their performance, as I said earlier, impedance is impacted by copper weight, trace length, trace width, and the dielectric from where those component, the impedance layer is. As we look at the impedance values in our PCBs and we develop the layout and the routing of it, we know where to place them, we know how the length of them, and we also know how to test them. So impedance testing of the circuit travel, if it's not correct, we'll know at production manufacturing. And running the test values at design, routing, and layout gives us the room to make changes. It also gives us the room to look at stack ups, what we can currently do with common stock, make changes to those trace widths so they'll be compatible with what you need. Testing comes into play at manufacturing. So all in-circuit testing for impedance are done on site at production. Another question that was asked was about manufacturing experts to avoid any last-minute design issues. So PCB designers, our PCB engineering team work closely at hand. The design is completed at our design group, passed to my engineering. They do a full DFM. As I said, they go back and forth with the design team if needed and make any changes or suggested corrections. And then we'll receive back the data set again from routing and layout, and we'll do another complete DFM on it. You don't receive the design package completed until we have reviewed it fully in engineering and we're confident that it can be processed with ease through manufacturing. What are some of the common mistakes or oversights frequently seen in PCB designs submitted by customers and how we can avoid them? So that's a loaded question, but some of the things that we see are bundled space and trace. So you have a 3 mil circuit, 3 mil spacing, and you bundle them together. So now you have a set of 15 traces that are up against each other that are only 3 mils wide, 3 mil spacing. Adding just a half a mil of space between those 3 mil traces makes manufacturing so much easier. Pad to hole ratios, not considering annular ring, not supplying any kind of netlist testing or netlist data to us so we can test out your data to be sure it's correct. Missing drawings, missing drill programs, just not enough information sometimes coming in the door. So what does Epec provide for layout services? So we do the layout and the routing with our supply chain, our design groups that we have across the United States. We have some outsourced suppliers as well. We work very closely with our domestic team of designers to do the routing and the layout because most of our customers are here as well. And being on the same continent, not necessarily the same time zone, is advantageous for communication. And that's about all I have time for. There are some more questions that have come in. But for now, I would just say that if you have anything you would like us to look at, if you're not a current customer, send us your design requests through our customer service or through our website. And we appreciate you all for spending some time with me. Thank you very much.